Welcome to Light Availability Enterprise. Today we'll be discussing the safety of your inverter. Safety of your inverter. And before me now, I have a sketch on how your inverter system is supposed to be designed to charge your battery and for your inverter to work safely. Now, on this sketch, you are going to see a spike here. This spike is what we call the lightning arrestor. Then we have the DC breaker, the surge protector, the solar charge controller, the battery, the DC breaker, then your inverter. Now, this arrangement is going to save the life of your inverter, save the life of what? Of your battery and even your charge controller. Because lightning, what we popularly call thunder, when lightning occurs, it has the ability to release up to 11,000 volts. And this 11,000 volts, if you strike or struck your controller or your inverter, it will damage the system. Your inverter does not have capacity to absorb that amount of voltage and still remain in good working condition. So in the top of your building, you first of all install a lightning arrestor on top of the building, as you can see on this sketch. Now, when the lightning arrestor has been installed on the top of the building, you now link a conductor to the ground. So if there is atmospheric discharge of up to 11,000 volts, the voltage will be attracted by what? By the lightning arrestor, and it will grind it. So therefore, here, this is the solar panel. The solar panel on the roof, they will be safe. They will become safe from the atmospheric discharge. Now, let's assume that the way the lightning struck your building, it is able to bypass the lightning arrestor. Or let's assume the lightning arrestor did not absorb all the charges from the atmospheric discharge. Let's assume some of the high voltage moved to your system. The moment it moved what? To your system, that lightning can pass the DC breaker. If it passes the what? The DC breaker, it will now go to what? To your surge protector. Now, what will the surge protector do? The surge protector is connected in parallel to your system, and it is connected in what? In series to what? To the ground. Now, any excess voltage that want to pass this surge protector, it will make the surge to close, because this surge and the earth has an open terminal. On normal condition, the surge terminals, that is the conductive terminal, are separated from the earthing terminal. But the moment there is extremely high voltage, they will close themselves. Now, closing themselves will allow the high voltage to go to what? To ground. So any excessive voltage that is coming will stop here. It will be unable to what? To go to your charge controller. And when that excessive voltage is being grinded, there will be excess currents. The excess currents can trip your breaker. So your breaker will trip off and keep your system very safe for you. So you want to ensure that there is lightning arrestor on the roof. This is your solar panels. To even provide more protection, you can equally earth your solar panels. Each of the panels will be linked together with a conductor. Then you will know what? You will grind it also, so that anyone that mistakenly falls on what? On the panels can what? Can go to the ground. But peradventure, if you escape to your system, there's a surge protector, a DC surge, that will go to sense excessive voltage, and it will close the system. It will close the system on what? On earth. Then your DC breaker can now trip off to keep your system very safe. Then from this DC breaker, you now have your solar charge controller. You now install your what? Your battery. Then your DC breaker again before your inverter. Why do you put this DC breaker here before your inverter? This inverter can become short-circuited, and once it becomes short-circuited, the battery parts can what? Can be short-circuited, and it can make your battery to explode, because excess current will be drawn from what? From the battery, and this excess current, it can damage your battery or even cut your battery cell. So this breaker will sense excess current being drained, it will trip off. So the moment this inverter, if it's meant to draw 100 amp from the battery, the moment there's a short circuit on this inverter, it will draw more than 100 amps. Therefore, your battery will become safe, because the breaker here will trip to keep your battery very safe. Now, our next video, I'm going to show you an illustration on how to safeguard your inverter if you want to charge it with the power authority, because many people used to use the power supply from the authority, from the grid, to charge their battery. So I will show you the sequence to save your inverter from this damage. Thank you very much.